So let's talk about some one-step mole problems with the mole mass and mole volume relationships under Chapter 10, Section 2. You should probably have your periodic table and polyatomic ion list ready. You should also probably have a calculator out because we are going to be doing some math problems in this video. At the end of the video, you should be able to convert amongst the mole and both mass and volume. We've already done amount and we've already talked about the molar mass. We're going to use molar mass again today, but the two new concepts are converting amongst the mole and mass and volume. I would copy down this flowchart into your notes somewhere. We're going to be using this flowchart a lot, and it has all to do with the mole. We talked about a couple days ago how the mole equals an amount. It's Avogadro's number worth of representative particles. Remember, Avogadro number is 6.02 times 10 to the 23rd. And representative particles could be atoms, molecules, ions, formula units, anything like that. So 1 mole equals Avogadro's number worth of representative particles. We also talked about how the mole also equals in mass the molar mass of a substance. So oxygen has a molar mass of 16 grams per mole. So 1 mole equals 16 grams. Or for carbon, 1 mole can equal 12 grams. So a mole can also be related to the mass using the molar mass. The new concept for today is that the mole can also be related to volume, and that's volume of a gas, specifically at STP. And we'll talk about STP in class tomorrow, but the number you need to remember is that 1 mole equals 22.4 liters of a gas at STP. So these three units are going to be important when doing some mole conversion problems. So let's go ahead and get started. How many grams are in 5.67 moles of NaOH? Again, extra credit opportunity here for someone who can tell me the name tomorrow during class of NaOH, thinking back to our Chapter 9 naming rules. The first thing for this problem you need to do, though, is determine the formula for the compound. And that's pretty simple. We have the compound in our problem, so I'm just going to rewrite it. NaOH. First step is done for us. The second step is to underline what I have. I have 5.67 moles. That's how much I have. Your third step is to circle where I want to go. The problem is asking me to get my answer in grams. So I'm going to circle grams. How many grams? I want grams. My answer should be in grams. So then we go ahead and look at the flowchart. Looking at the flowchart, I have moles, so I'm going to put a star like they do at the map if you're at the mall or something. I'm at moles, and I want to get to mass. X marks the spot, like a treasure hunt. So I have to go this way, which means I'm going to have to use the molar mass of a substance. So using my flowchart and knowing that I have to find the molar mass, I'm going to go ahead and find the molar mass. So I have NaOH, and to find the molar mass, if you don't know how to do that, I would review the video on molar mass first. But we have to count the number of atoms for each one, and we have 1 Na, we have 1 oxygen, and we have 1 hydrogen. Second step is to find the molar mass off of the periodic table for each of the elements. Na is going to be 23 off of the periodic table. Oxygen is 16. Hydrogen is 1. So this is 23 here. This is 16 here. This is 1. Then to find the total of the molecule, we have to add them together. So the answer here is going to be 40. And this is 40 grams per mole. So NaOH has a molar mass of 40 grams per mole. The next thing to do then is to solve the problem using dimensional analysis. And we reviewed dimensional analysis before, but if you need more help, I would review the video on Chapter 3 for this. But for dimensional analysis, we put what we are given first. We're given 5.67 moles of NaOH. Then we draw a railroad track. The moles of NaOH goes on the bottom because these units need to cancel out. And so then we put grams, which is what we want, on top, grams of NaOH. And in every 1 mole of NaOH, there are 40 grams. So I use the conversion factor here that I calculated using the molar mass. And then I just multiply across. So 5.67 times 40 gives me 226.8 grams of NaOH. And that's my answer. Let's go ahead and try another one. So how many moles are in 45.76 liters of carbon monoxide gas at STP? First step is to determine the formula for the compound. The compound is carbon monoxide. Carbon monoxide is CO. Again, review section 9.3 rules if you could not get that formula, because you need to be able to do that. Second step is underline what I have. I have 45.76 liters. Circle where I want to go. It's asking me how many moles are in 45.76 liters. So then now I look at my flowchart. I have liters right here, so I'm going to put a star. And I want to get to moles. X marks the spot. So I got to go this way. Okay? So now I know where I want to go. And I go ahead, and the fifth step was to find the molar mass. But wait. It says find the molar mass, but according to my flowchart, I'm here, and I want to get to here. The molar mass is over here, so do I need to use it? I don't think so, because I only want to go from here to here. So I don't need to use a molar mass. I actually need to use 22.4 liters of a gas. So we have carbon monoxide, and 1 mole equals 22.4 liters. That's my conversion factor. So I don't need to find the molar mass. And I just need to use dimensional analysis to solve the problem. So 45.76 liters of carbon monoxide. Make my railroad track. I put liters of carbon monoxide on the bottom because my units need to cancel. And then I put moles of carbon monoxide on top. So 1 mole is equal to 22.4 liters. That's my conversion factor. And so now I divide 45.76 divided by 22.4, and I get 2.04 moles of carbon monoxide. This flowchart is going to be very useful. It's going to be important for you to be able to use because it's going to help you determine which conversion factors you need to use. Either Avogadro's number over here for amount, 22.4 liters of a gas for volume, and then the molar mass of a substance. It will also help you figure out if you need to find the molar mass and do that extra step. Sometimes you might not need to find the molar mass, so why waste that time? So today we talked about mass and volume and converting with them in the mole. And combined with everything that we've done, we are almost done with our objectives. So come back tomorrow prepared to do more conversion factor problems. Okay, have a good night.